When you write a select statement, I'm guessing you probably rely on certain assumptions. For example, how about the famous select star? We probably assume that it returns all columns in the referenced object. If you do select star from some table, you get all the columns in some table. Here's another assumption. Each column in the results that you get comes back in a separate column. That one almost sounds confusing. It's just so obvious, right? Or at least we might think it is. And then how about each column that's in the result set actually shows up in your result set grid? If your query returns 9 columns, you should see 9 columns of data in your result set grid. Well, it turns out, at least with Microsoft SQL Server, that all of these don't hold true. So let's take a look. Here's a little simple table. Looks like we've got 4 columns in the table, right? Yeah. All right. Yeah. Actually, there's 6 columns. Or, that is 6, right? So what's going on here? Well, let's see what we can find out if we look in the column metadata. So if you've never looked in object metadata before, this is a system view that SQL Server provides where you can go and view the details of how each column is defined. Now we can see here that, yes, there actually are 6 columns. So we're wondering why we couldn't see those columns to start with. So I'm going to scroll way over here to this is hidden column. And you'll notice the last 2 columns, start time and end time, both are marked hidden. So now the question is, why? So let's take a look at the create statement we just used. This is a temporal table. We won't get to go into that in depth right now, but a temporal table is basically a way for you to ask SQL Server, instead of just tracking the value in this row, track it over time as it changes. Well, if you're tracking something that changes over time, you need a start date and an end date, or a start time and an end time. When you define a temporal table and you define those start and end time columns, you can say hidden. And if it's marked as hidden, it's going to not show up by default in your select statement. Not show up by default if you do a select star query. So jumping back over here to our columns data, we saw this as hidden, but it still doesn't tell us why. So I'll just scroll over here and we'll see that right in here we have this generated always type and generated always description. Since those have values in them, we can tell that they're hidden because they're generated columns. So that's our first example where select star didn't return everything in the table. Here's another one for you. All right, can anyone tell me what kind of a table we're looking at now? All right, this is a graph database table. So SQL 2017 introduced support for graph databases, which we had a great talk on, was it last time? We can tell this is a graph table by the style of the column name on the first column. But again, we're trying to find cases where we're missing columns. There's actually another column to this table. But this time, if I try to get it out, I'm going to get an interesting error. Cannot access internal graph column and a very long name. So again, let's take a look and see what this looks like in the column metadata. Let me try running just the right query. And now we can see that indeed there is that funny named column. Let's go way over here again. Yes, indeed, it is hidden. Give you a clue. The answer to why it's hidden is right here. It is the graph ID column. You cannot directly select a graph ID column. Now, there is a column there with data in it. You can't directly select it. Can you get the data out of that column? Let me see if I can remember. I had to write down this function name because I don't type this one in often. See if I got that right. Nope. There we are. So I had to use this special function that was just added in SQL 2017 to pull out the graph ID from the node ID. Now you'll notice also that that funny node ID column name, that $node ID, doesn't match the column name we see down here. This is called a pseudo column name, and it just saves you from having to type that fancy long name. You'll see the similar behavior if you work with edge tables. We can see right here, this was a node table. If you're doing a graph edge table, you actually have 3, 4, 5 hidden columns, and so there's functions you can use to pull that data out if you need it. So we've looked at 2 cases where you have columns that don't come back when you do select star. Now we're going to look at a case where you have you can have many columns that come back as one column. Now, at first glance, you might think this second column, the attribute column, is actually an XML column. And it kind of is. But it's not your ordinary XML data in this column. Let's just take a look at what we can see here. We can see that this one has an attribute 1 with 10. And I'll make this larger. This one has an attribute 2 with a very long number. Now watch this. Now they all show up as separate columns. This is a sparse table with a column set. So if you have a set of columns where most of those, a very large set of columns where most of those columns are going to be null, it's more efficient from the database perspective to tell it, hey, most of these are always going to be null. So factor that in how you store this. So the database stores it a little differently internally, and it sends it across the wire differently. You can see it comes across as an XML element, where each column that has a value shows up in that XML element or column, and the rest are left out. This is something you might use if you had hundreds of columns where 1 or 2 or 3 are actually going to have a value and the rest are going to be null. Again, jumping back to metadata, so if you run into this in real life, how you can identify what's going on. There we are. Now again, nothing was hidden this time, but what we can do on this column is scroll over and we can see that these are sparse columns, the middle 3, and then the bottom one is a column set. So back to the column definition, here are my sparse columns, and then here's where I defined the name for the column set, that it was a column set, and that I want it, that all sparse columns are supposed to be in that column set. Just because you have a sparse column doesn't mean it's going to end up in, that you need to have a column set. So far we've hit 3 situations, kind of brain teases, something you might hit in real life and really scratch your head wondering. Maybe it'll save you from that, and I think we'll pause for a question. Yeah.
So does this have any character limits on this, or is this stored as log data, or does it have a character limit?
My guess is it's going to be the size of the XML element, but I can't remember that. Does anyone remember?
I believe XML is log, is it not?
Yes, it is.
So,
I can't remember the limits on sparse, but I think it's pretty big, so probably lob or maybe special for the XML element. So the question was, does a sparse column set, what are the limits in size there? That's the question we just tried to answer. Now, this last one, gonna be the opposite of what we started with. Instead of looking at queries where you were missing columns and you had to ask for them, we're gonna look at a query where you get more data than you asked for, but you can't see it. And it poses an interesting security concern. So let's step through this slowly. Here's a view. You might find this in a corporate environment. We're gonna pretend this is privileged human resources data that's been sanitized for wide consumption. You know, we're not showing you the full birth date. We're not showing you the real hire date. But this looks like 4 columns, right? Let's look at what this looks like as it crosses the wire. So I'm gonna start up a packet sniffer here. And I'll go ahead and run this in SQL CMD. It's Microsoft Message Analyzer. So it's kind of the replacement for Microsoft's Netmon, I think they used to call it. Make sure we got the right database. You can see we got a lot of TDS traffic already. All right, again, our 4 columns. Let's just prove that that's really what happened. Here's the TDS packet, here's the column metadata. Result set starts with column metadata, and we can see 4 columns. Now we're gonna switch on one version of browse mode. It's a legacy mode built into SQL Server to support some concurrency type things. I've never even been able to see a really good explanation of what it's used for these days. You probably are gonna, if you're gonna use it, you're gonna be using that's all right. That's all right. So it's a legacy mode that you probably never heard of and probably have never used consciously, but it's still there and you can't turn it off. All right, so I just turned on browse mode. I'm gonna repeat my last query. 4 columns again. Let's look at our result, at our TDS packet here. How many columns does it say? All right, so let's look back at, we had first name, last name, birthday, and employed since. Let's look at what actually came across the wire. First name, last name, birthday. All right, employed since, no surprises, and the mystery. Social security number. And we've got username, history ID, and these last 2 are both date columns. We could look at the other one. All right, so what happened now? Let's go back and look at how this column was defined, or how this view, I should say, was defined. So we have a view with a bunch of joins, and you can kind of see that some of those columns are present in the join, even though they're not in the select statement. But then I just mentioned history ID. That's not in the join here. You don't see it anywhere in this query. Actually, these are the list of keys defined on the tables that are used in the join, whether or not they're in the query. Because browse mode requires this data to operate on the client end. Well, the good news is you don't have to completely panic, because this data will only be sent if you have access to the underlying tables. But it does mean someone who's nefarious can get around auditing if you're just doing a simple query select statement audit, where you're just looking for people querying that birthday view, and you say, or you don't care because it's supposed to be safe data. So someone who turns browse mode on can pull restricted data
Does it require advanced privileges to be able to turn browse mode on?
No, every user has that option.
So it's public or advanced permission?
Yeah, if you have access to select, you can enable it. Again, the question was, does it require advanced permissions to turn browse mode on? The answer is no. If you can select, you can turn it on. So, again, the security risk is not as phenomenal as anyone getting privileged data out, but if you already have access to those columns, if a user does, it allows them to escape potentially some audit monitoring, because now they can pull through this safe view privileged data. And you also have to watch for this if you use stored procedures that use execute as, because you give a non-privileged user execute rights to a stored procedure, but then that stored procedure does a context switch using execute as, the browse mode flag passes through, and so now the queries run under with the browse flag, but under the context of that privileged account. So here we've just had 4 cases where select either leaves out some columns, displays columns in the result set displays columns the different number of columns than you asked for, but all the data's there, or doesn't show you all the columns. A little fun, maybe it's useful. Hopefully it'll save you from banging your head on the wall one day. Thank you.